Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0161, is associated with the front secondary heated oxygen sensor, specifically referred to as the secondary HO2S, Bank 2, Sensor 2, heater circuit malfunction. This component plays a vital role in monitoring the oxygen content in the exhaust gases. The primary function of the oxygen sensor is to provide feedback to the engine control module or powertrain control module, PCM, regarding the efficiency of the combustion process. It does this by sending voltage signals that vary with the oxygen levels in the exhaust. The heater within this sensor enhances its temperature during cold starts, which helps in stabilizing its readings by ensuring the sensor is warmed up quickly. An issue is detected when the heater draws an incorrect amount of amperage, either too low or too high, which results in the PCM logging this DTC. The subsequent troubleshooting process is crucial to determine the root cause of the malfunction. After completing the necessary repairs based on the previous steps, the final verification process is crucial. The first action should be to reconnect any components or wiring that was inspected or repaired. Then, a thorough retest of the entire system is necessary to ensure that all connections are secure and functioning correctly. Driving the vehicle under varied conditions is recommended to confirm that the DTC P0161 does not reappear. The final step is to check the diagnostic tool for any remaining trouble codes. Clearing residual codes is essential before concluding the repair process, as this confirms that the previous issues have been resolved. Preventive maintenance is essential to avoid future occurrences of DTC P0161. Regular inspections of the wiring associated with the front secondary heated oxygen sensor should be performed, as exposed wires can lead to shorts or breaks due to vibration and heat exposure. Keeping the electrical connections clean and secure is crucial in maintaining optimal performance. Additionally, monitoring the vehicle's performance can help identify early signs of issues related to the oxygen sensor or PCM. Conducting these preventive measures regularly aids in early detection of potential problems, helping to ensure proper operation and compliance with emission standards. In conclusion, DTC P0161 indicates a critical malfunction in the front secondary heated oxygen sensor's heater circuit. Understanding the role of this sensor and its components is vital for effective troubleshooting and repair. The process involves confirming the fault, inspecting wiring, testing circuit amperage, and ensuring the proper function of the powertrain control module. Additionally, regular preventative maintenance can help reduce the chance of recurring issues. Addressing this DTC promptly ensures optimal engine performance and adherence to emission standards, promoting a smoother vehicle operation overall. The error described by DTC P0161 pertains to a malfunction in the heater circuit of the front secondary heated oxygen sensor, specifically Bank 2, Sensor 2. This sensor's heater is essential for ensuring the temperature reaches optimal levels quickly, promoting accurate oxygen content detection in the exhaust. Located in the exhaust system, the secondary HO2S is critical for ensuring emissions regulations are met and the engine runs efficiently. When operating improperly, it can lead to increased emissions and poor engine performance. The PCM, or Powertrain Control Module, regulates this heater's function. Thus, any deviation in its amperage draw indicates a malfunction. This could be due to several factors, which we will explore in the following slides. There are several possible causes for the DTC P0161 error related to the front secondary heated oxygen sensor. The first probable cause could be a failure within the heater of the sensor itself, which impairs its function to heat adequately. Another possibility is an issue with the SO2-HTB2 line, either being open or shorted to ground, both of which would severely affect the heater's ability to operate. Additionally, a power supply line that is open, including a blown fuse, can disrupt the heater circuit entirely. Furthermore, if the PCM experiences an internal circuit failure, it may not correctly command the heater, resulting in this DTC error. It's crucial to investigate all these potential sources to identify the exact cause. When the DTC P0161 is present, several symptoms may be observed. One of the most evident signs is the illumination of the check engine light, which serves as an indication from the vehicle's onboard diagnostic system that there is a malfunction. Drivers may also notice a decrease in engine performance, including issues like rough idling, reduced power, or hesitation during acceleration, as the oxygen sensor provides inaccurate data to the PCM. Increased exhaust emissions may result as well, potentially leading the vehicle to fail emission tests. These symptoms underscore the importance of promptly addressing any DTCs, as they can have significant implications for both vehicle performance and environmental compliance. The first step in the troubleshooting process for DTC P0161 involves confirming that this specific code is indeed set and active in the vehicle's onboard diagnostic system. It's essential to utilize a diagnostic scan tool to access the PCM and verify the DTC information. Additionally, it is crucial to check for the presence of any other diagnostic trouble codes, especially DTCs P0117 and P0118, which could prevent the oxygen sensor monitor from running. Identifying any related codes helps to narrow down the possibilities of what might be malfunctioning within the engine systems. Documenting all active errors before proceeding further is vital, as it guides the technician in understanding other underlying issues that may affect the heater circuit functionality. In this second step, the focus shifts to inspecting the SO2-HTB2 line connected to the front secondary heated oxygen sensor. Technicians should check for any breaks or shorts within the wiring that may compromise the signal and functionality of the heater circuit. Utilizing a multimeter to check for continuity and resistance is recommended. An open circuit or insufficient resistance indicates a fault. If any issues are detected, these should be addressed immediately. Repairing any damaged wiring or connectors will be crucial to restoring proper function. It's important to ensure any connections are secure and free from corrosion, which could also lead to intermittent issues. The next step in troubleshooting DTC P0161 involves testing the amperage drawn by the heater circuit of the front secondary heated oxygen sensor. This test must be conducted while the engine is running and the heater circuit is activated. The actual amperage reading should be compared with the specified range provided in the service manual. If the current is measured at 0.38 amps or less, or 3.33 amps or more, it confirms a malfunction exists. This step is crucial in diagnosing whether the issue stems from the sensor itself or the powertrain control module, PCM. Documenting the results of this test will provide valuable insights into the condition of the oxygen sensor's heater circuit for further troubleshooting. During the fourth step, technicians should inspect the connections at the powertrain control module, or PCM. Loose or corroded connections can lead to undesired issues, interfering with the PCM's ability to communicate effectively with the front secondary heated oxygen sensor. Visually examining the connectors for corrosion, dirt, or damage is vital, as these obstructions can impact electrical signals. If any discrepancies are found, Cleaning or repairing the connections will help restore the connection integrity. Ensuring that all connections are tight and corrosion-free will optimize the performance of both the sensor and the PCM. The fifth step is to perform a self-test of the PCM to check for any internal failures that might affect its functionality. Utilizing a diagnostic tool that can interface with the PCM's self-diagnostic functions is essential. This step ensures that the control module is operating as expected and that it can regulate the heater circuit for the sensor properly. If any internal faults are indicated by the PCM during testing, it may necessitate further investigation or even replacement of the unit. Ensuring the PCM operates correctly is prime to solving the malfunction and ensuring proper communication with all connected components. Please like and subscribe to the channel. See you next time.